Okay, for your sound worksheet, most of you did a good job. So I'm just going to highlight your common errors. Okay, for your question 2, most of you point out that the density of solid is larger than liquid, and then you comment on the particles being more compact. So that is fine. However, a small number of you, right, you all commented that solid has more particles than liquid. So that part, it is wrong, because once you say that solid has more particle, you are actually referring to the mass and not the density. So please go and do your correction. I will be asking all of you to submit your correction and check. So if you have made this error, please write it down. For those who didn't make this error, please also put a note. So you can put a note like this. You can say that, okay, for things like, if you mention solid has more particle than liquid, okay, this is wrong. Okay, because once you go and comment on the amount of particle, this guy here, you are referring to the mass, which is wrong. You want to refer to the density, which is actually how compact the particle is. Then secondly, some of you ended the explanation with transmission of sound, therefore is faster in solid wire vibration. So actually that is not so good, because you want to show your understanding on the subject matter. So because of that, most of the time when we are explaining this kind of question, we would use the term the transmission of vibration, because essentially sound waves are just waves of vibration. So transmission of vibration is faster in solid. So those of you that I circle transmission of sound and then I circle the sound, because I want you to use this phrase, transmission of vibration. So you need to learn how to use this standard way of phrasing. Question 3, most of you get correct. There's no upper limit for ultrasonic frequency. Okay, so you just need to tell me that it's more than 20k hertz. Okay, then for your calculation question 4a, those who got it wrong, you all have forgotten what is the meaning of kilohertz. So actually 120 kilohertz is 120 times 10 to the power of 3 hertz. Okay, so those of you who got it wrong because you didn't account for this prefix, so please do your own correction there. Then for the echo question, I told many of you to actually trace the sound, the path of the sound. So what happens is that the emitter will send a path down. So this is 1D, and then after that it will echo up. That's 2D. So actually for the time that the time taken for this 15 seconds, okay, this 15 seconds is for this entire path, so it involves 2D. Okay, so actually your formula, when you are using it, the total distance traveled is 2 times the depth, then the speed of sound in water multiplied by 15 seconds. Then you can find the D directly. Okay, so please work it out yourself. As for your part B, this is another type of calculation question, and it doesn't involve echo. So for this type of question, you need to have the understanding that sound travels faster in water than in air. So actually the sound path, after you trace it, should be like that. One path in the sea, the other path in air. Okay, so there are 2 approaches to solve this question. You can either say that the distance traveled in the sea is equals to the distance traveled in air, and then after that you can expand this. What is meant by expansion? You change the distance into speed times time. So the speed of sound in air is 340 multiplied by t plus 1. Why t plus 1? Because it is mentioned in the question that the 2 sound is actually separated by 1 second. So because sound travels slower in air, so the plus 1 goes to the air side. Okay, then on the left hand side is the distance traveled in the sea, right? So you just take the speed of sound in water multiplied by the time, and you can solve for what is t. once you solve for what is t, you can then work out your distance equals to speed in the c multiplied by t. Then this will be your final answer. Okay, so this is one approach of doing it. Then there is another approach. That is to say that the other approach, you work it out yourself, but the starting expression will be the time travel in air minus the time travel in the sea is equals to 1 second. And then you expand this in distance over speed. Okay, and you will be able to get the distance directly from this expression. Okay, question 5 is the one that I want to spend more time on. So most of you are able to identify that this is compression and this is refraction. But when I asked you to comment on the displacement, most of you commented that at the compression, the particles are squeezing to each other, and then refraction, they are spreading out. But that is not displacement. So if you read the context of the question carefully, they say that these lines represent the original position of the particle, and this dot are the position of the particle at a certain instance. So if you look at the region of compression and the region of refraction, you will find that the dot and the line are at the same place. So what this means in terms of displacement is that at the compression and refraction, the displacement is actually 0. And once you have this insight, it will actually allow you to identify where is C and where is R on the graph, which is in part E. Okay, then for part C, those who got it wrong, you forget that wavelength is compression to compression. Okay, so most of you measure the distance between compression and refraction, and you will get, I think, 5.9 or 5.6 or something like that lah. So in the end, down here the answer should be 11.8 cm. Okay, as for amplitude, amplitude means current position, maximum current position minus initial position, and the maximum comes here. So you need to measure the distance from here to here, which is about 0.7 cm. Okay, so that's how you do this. Okay, the boys did very terribly in part E. Whenever you are sketching something, the first thing you should take note of is what you call that, the axis label. So down here you should have your displacement, and then remember the unit, which is in cm. Okay, you need to refer to your part C down here. Okay, everything is measured in cm, so because of that your unit should be in cm. Down here you have position, and I think that because it is called position, you think that there's no unit. Actually not. Position can be measured by cm as well. Okay, so you need to have cm. So how you sketch? Basically it is just a standard sine wave. So do your sine wave. Okay, if you can sketch nicely like me, you can freehand. But for those who can't, what I suggest you to do is you measure interval 1, 2, 3, 4, 5, 6, 7, 8. Agak-agak lah. Then after that, mark out the upper and lower limit. Okay, they should be about the same. Then for these limits here, you refer to your answer in part D. Okay, which is the amplitude here. Okay, so I have given you error carry forward. So down here, remember on top is positive, below is negative. Okay, then I suggest you go and use your ruler to ensure that your entire wave is kept within the upper and lower limit, which is your amplitude. Okay, for how to draw a wave, very simple. You start at here, it will go to here. So you see I will dot first. Go up here, go to here, go back down here, come to here. So once I have that, I will just draw. So it is a sketch. Need not to be very accurate, but if you look at this part, it's ridiculous. just remove it and draw nicely. Okay, so where is the compression and refraction? So earlier you have learned that at compression and refraction, the displacement is actually 0. So if you look at your graph, where is the line whereby displacement is 0? It's actually the x-axis. So because of that, your compression is actually here or here. Okay, after you label the refraction and compression, you also need to make use of the answer in C, which is this number here. Which is this number here. So what is this? This is actually the wavelength of the wave. So if you look at your sketch, this is one complete wavelength, and so you need to indicate that at this point here, it is 11.8. Okay, and once you have this item, and this item, you have make use of all the information that you can gather for this wave, and your sketch is completed. Then this will be your compression. For part G, they are asking you what will happen if I wait for half a period. So if I wait for a full 1 period, this thing here would have appear, the peak will have appeared here. So half a period means that my peak, instead of appearing here, 1, 2, 3, 4, 5, right, it will appear at where? Around here. Where the peak will appear, my peak appear here, then it will appear here, right? So from here to here is 1 whole period. So half a period means it will appear here. So the new wave would look something like this, and you shouldn't leave this part blank. Okay, so please do your correction. Question 6, you can refer to the textbook and find what's the answer.